Hello and Assalamualaikum. I'm Nur Ajira binti Muhammad Azmi. Today, I will talk about a project entitled A Novel Graphene Chitosan Sensor for VOC Gases.
A little bit about my background study. I'm student from University Technical Malaysia Melaka from Faculty of Electronic and Computer Technology and Engineering, and for this project I have been supervised by Dr. Siti Amaniah binti Muhammad Chajuli and also Dr. Nur Hazashah binti Samsudin.
Detecting VOC gases such as acetone and ethanol is a critical concern for public health and environment safety. This project aimed to develop a novel using graphene chitosan gas sensor for volatile organic compound and to analyze the characteristics of the sensor in terms of response time and also recovery time. As for the problem statement, first, the detection, monitoring and analysis of the VOC gases is a topic of rising interest in the field of gas sensor development. Most of the available sensors are expensive and suffer from high power consumption, poor stability, inflexibility and malfunction in harsh environment. Therefore, polymer-based gas sensor has been proven to enhance the performance of the gas sensor due to their easy fabrication, low cost, high reproducibility and flexibility compared to the conventional sensor. Second, volatile organic compound such as ethanol and acetone, which include toxic gases and contaminant produced by industrial process, are hazardous to human cardiovascular and respiration system, as prolonged exposure to the ethanol vapor at exposure limit volume ROLI 3.3% to 90% can cause nausea, skin rashes, Parkinson's disease and bronchitis, while exposure to acetone vapor can lead to the symptoms like bronchitis, weariness, disorientation and organ damage. Now, let's continue to the preparation of the graphene chitosan gas sensor.
In preparation of polymer solution, 0.5 gram of chitosan powder will dissolve into 20 ml of acetic acid to become polymer solution. The solution will heated and stirred at temperature 100 Celsius and 500 rpm for 3 hours. 4.75 gram of polymer solution will mix with 0.25 gram of graphene to become paste. The mixtures will stir at 40 Celsius and 80 rpm for 24 hours. Kapton film substrate were used as the substrate of the gas sensor. The interdigital electrode was deposited onto the Kapton substrate by using a screen printing technique. Firstly, an amount of silver paste was placed into the frame, then the paste was scraped across the screen surface using a squeegee. Squeegee pressure transfer paste material into the substrate by following a pattern on the stencil. As a result, the design is transferred to the substrate and the paste layer is deposited. The electrode was then annealed at 150 Celsius for 10 minutes in the oven. For second layer, the sensing material paste that has been prepared was coated onto the printed electrode using the Dr. Bake technique. This technique is done by pressing an amount of graphene paste, then deposit on the sensor surface and spread to provide a homogeneous sensitivity layer at 1 cm square. The area on which the material was deposited was controlled by developing a 1 cm square of area using scotch tape. The squeegee was placed over the substrate at the consistent velocity with a specific contact angle and height in this process. The movement of the squeegee uniformly distribute the paste onto the substrate, resulting a thick film gas sensor. Lastly, the sample was annealed at 150 Celsius for 30 minutes in the oven. This procedure was applied with two variables coated by one layer of sensing material and another by two layers of sensing material to cover the entire sensing area. This video depicts the process for measuring gas sensor response to acetone and ethanol. The acetone solution was filled in glassware and the vapor is flowed inside the gas chamber via silicone hose. The acetone solution was made by mixing 25 ml of acetone or ethanol with 25 ml of distilled water with a magnetic stirrer at 100 rpm for 5 minutes. The solution is then heated to 120 Celsius for 30 minutes to produce acetone or ethanol vapor. The current measurement process started with exposing the sample to air for 50 minutes to ensure that it has stabilized at standard atmospheric pressure. It can be seen that all the gas sensors cannot reach the stability in air after 50 minutes. After that, the gas chamber hose was connected to the acetone vapor for 30 minutes. The current value keep increase during this period for all gas sensors, and it indicate the response of the sensor to acetone similar with previous research, which is P-type gas sensor. The glassware hose was withdrawn from the gas chamber after 30 minutes and the recovery time was recorded for 50 minutes. Among them, T21 sample 2 and T22 sample 3 showed saturated current when exposed to the acetone vapor, while other gas sensors were unable to saturate in 30 minutes. Double layer was greater significantly than its single layer, with a consistent response within the range of 1.0123 to 1.0699. The greatest response value is 1.0703 and the lowest value is 1.0041. As for the response time, the single layer show a faster response time compared to double layer, which is between 3 minutes to 27 minutes. The highest response time produced by T21 sample 3, which is 3 minutes, and the lowest response time produced by T22 sample 1, which is in 29 minutes. Lastly, for recovery characteristic, most of the sample were unable to recover after the exposure to the acetone in 30 minutes. As for the ethanol, the double layer is more significant than the single layer with a consistent response between 1.0207 to 1.0532. The highest response is 1.1389, which is at sample T22 sample 2, and the lowest is 1.0089 at sample T21 sample 3. In terms of response time, the single layer respond faster than the double layer, taking between 21 minutes to 29 minutes. The highest response time is T22 sample 2 in 17 minutes, and the lowest is T21 sample 3, which is in 29 minutes. Regarding recovery, most sample couldn't recover after 30 minutes of exposure to acetone.
Conclusion: the comparison of the gas sensor response to acetone and ethanol in this study highlight the promising performance of the novel binder. The response value obtained in this work, particularly 1.0703 for acetone and 1.0532 for ethanol, demonstrate its potential of fabricating effectively gas sensor for VOC gases. That's all from me. Thank you for watching. Bye bye.